Dear students, अस्सलाम वालेकुम रहमतुल्लाहि व बरकातहू। जैसे कि आप जानते हैं, कल हमने एक नए टॉपिक की शुरुआत की नॉमेनक्लेचर को कंप्लीट करने के बाद, तो दैट इज़ आइसोमेरिज्म। तो आइसोमेरिज्म के बारे में कल मैंने आपको बता दिया कि आइसोमेरिज्म है क्या। Compounds having same molecular formula but different properties are called as isomers, and the phenomenon is called as isomerism. This isomerism of two types, structural isomerism and stereoisomerism. And we have yesterday discussed some types of structural isomerism. As has been discussed, that structural isomerism is that in which two or more compounds have the same molecular formula, but they differ in their structures, or rather in their structural formula. So these compounds which differ in their structural formula and having same molecular formula are called as structural isomers. These structural isomers are of many types. One of the types is chain isomerism. And in this chain isomerism, we observe that the two compounds which are isomers of each other, they differ in the arrangement of carbon atoms. As you have seen, normal butane and isobutane. In normal butane, the four carbon atoms are in a straight line, while as in isobutane, there is one carbon atom which stands as a branch. In the same way, in case of pentane, there are four carbon atoms and five carbon atoms in a straight line, so that's normal pentane. Then there is another type of pentane which we call isopentane, where there are four carbon atoms in a straight line and one of the carbon atoms is present as a branch on carbon number 2. This compound is called as isopentane. And then there is another third type of pentane where there are four methyl groups attached to the same carbon, or you may say why there are three carbon atoms in a straight line and two alkyl groups, two methyl groups are present as branch on carbon number 2. In this way, this pentane is called as neopentane. So this pentane has three isomers. One is normal pentane, another is isopentane, third one is neopentane, and all these three have the same molecular formula C5H12. So this type of isomerism, where compounds differ in the arrangement of carbon atoms, such compounds are called as chain isomers. Then we discussed another type of isomerism which is called as positional isomerism. In this type of isomerism, we observed that the arrangement of carbon atoms in the two compounds is same. They differ in the position of the multiple bond or in the position of the functional group. As you have seen in this compound, this is but1-ene and this compound is but2-ene. The difference in these two compounds lies in the position of the double bond. In compound first, it is on carbon number 1, and in compound second, it is on carbon number 2. In the same way, you can see this compound here, it is propane 1 all. Here OH group is present on carbon number 1, and in this next compound OH group is present on carbon number 2. Both these compounds have same molecular formula, they have same arrangement of carbon atoms. They differ in the position of functional group OH. In one it is on carbon number 1 and in another it is on carbon number 2. So such isomers are called as positional isomers. So today we will discuss the third type of isomerism, structural isomerism, that is called as functional isomerism. It is very simple to understand. Functional isomerism. Functional isomerism means that type of isomerism in which the two compounds have same molecular formula. The two or more compounds, the two or more compounds having same molecular formula, having same molecular formula, but they differ in the nature of the functional group, or rather they have different functional groups. Compounds having same molecular formula but different functional groups are called as functional isomers. There are many types of functional isomers. One of the examples is alcohols and ethers. Alcohols and ethers. There are so many compounds among alcohols and ethers which have same molecular formula but differ in the function. Some, for example, you may see in this way, there is compound CH3CH2OH. You see, this compound is ethanol. This is ethanol. It is an alcohol. Now let us see one more compound, CH3OCH3. You see, this compound is dimethyl ether. It is dimethyl ether is its common name. Its IUPAC name is methoxymethane. OCH3 group is methoxy group. This is methane, methoxymethane. Now you see these two compounds, ethanol and methoxymethane. They have same molecular formula, C2H6O. C2H6O. So C2H6O, it is the molecular formula for ethanol as well as dimethyl ether. So this ethanol and ether, dimethyl ether, they are functional isomers of each other. Another example is between carboxylic acids, and esters. Carboxylic acids and esters, they also show this functional isomerism. For example, this is the compound CH3COOH. This is acid, CH3COOH, acetic acid or ethanoic acid. Now see, HCOOCH3, HCOOCH3. This is methoxymethanoic acid or methoxymethanoate. You may call this compound as methoxy sorry, it is called as methyl formate. Its common name is methyl formate, or its IUPAC name is methyl methanoate. Methyl, its IUPAC name is methyl methanoate. It is methanoic acid. Its IUPAC name is methyl methanoate. Since this is formic acid, its common name will become methyl formate. So this is ethanoic acid. So these two compounds, ethanoic acid and methyl formate or methyl methanoate, these two are functional isomers of each other as they have different functional groups. In the same way, aldehydes, ketones, aldehydes and ketones, aldehydes and ketones also show this type of isomerism, which we call functional isomerism. Aldehydes and ketones, you see, suppose the compound CH3CH2CHO. This is aldehyde, CH3CH2CHO. It is propanol, 1 2 3, 1 2 and 3 carbon atoms are there, so it is propanol. Now let us see another compound. This is propanol. See another compound, CH3 C double bond O CH3. You see, it is ketone, CH3 C double bond O CH3. The common name of this ketone is acetone, and its IUPAC name is propanone. Since there are 3 carbon atoms, so it is propanone. Propanone and propanol. Now you compare their molecular formula. They have 1, 2 and 3 carbon atoms. So C3, H3 and 2, 5 and 1, 5 hydrogen atoms, and there is 1 oxygen atom. So C3H5, 1, 2 and 3 carbon atoms. There are 3 and 2 or 5 and 1 are 6 hydrogen atoms and 1 oxygen atom. So its molecular formula becomes C3H6O. C3H6O. Now see another compound which we called propanone. It has 3 carbon atoms also, 1, 2 and 3, and there are 6 hydrogen atoms, 3 on this carbon and 3 on this R. So its formula is C3H6O. C3H6O. So both these two compounds, propanol and propanone, they have same molecular formula, but they have different functional groups, so they are functional isomers of each other. In the same way, there are so many other examples where you will observe this type of functional group, functional isomerism. For example, there are aromatic aldehydes, aromatic aldehydes, then aromatic ethers, and then there are phenols. They also show isomerism, functional isomerism. For example, you see this compound. This is the compound CH2OH. This is benzyl alcohol. Benzyl alcohol. Then you see this compound OCH3. This is ether, methyl phenyl ether, methyl phenyl ether. Then you see this compound. You see this compound. It is OH here. It is supposed CH3 here. This compound is phenol. This is aromatic phenol. This is aromatic ether. This is aromatic alcohol. So all these three compounds have same molecular formula, but they have different functional groups in them. So they are functional isomers. In the same way, there are nitro compounds and nitrites. Nitro compounds and nitrites. They also act as isomers. You see, for example, there is a compound CH3, CH2, and double bond O, single bond or coordinate bond O. Then you see CH3, CH2, O, and double bond O. These two compounds. The upper one, it is nitro compound, and this one, it is nitrite. Both these two compounds have same molecular formula. You see, they have two carbon atoms. There are two carbon. There are 3 and 2, 5 hydrogen atoms. Here are 3 and 2, 5 hydrogen atoms. Here is one nitrogen. Here is one nitrogen. Here are two oxygen atoms. Here are two oxygen atoms. So these two compounds, nitro compounds and nitrites, they also provide us an example of functional isomers. In the same way, there are cyanides and isocyanides. Cyanides and isocyanides, which we also call nitriles and isonitriles. For example, this is a compound CH3C triple bond N. Then there is a compound CH3N double bond coordinate bond C. In this way, these two compounds, they are having same molecular formula. See, two carbons are here. Here there are two carbons. There are three hydrogens. Here are also three hydrogens. There is one nitrogen. Here is also one nitrogen. So these two compounds, they have same molecular formula, but they have different functional groups. So they are once again functional isomers of each other. So this functional isomerism, it exists in a number of compounds. There are many examples of functional isomers. Then this was the third type of isomerism, functional isomerism. Then there is another type, fourth type of isomerism, that is called as metamerism. That is called as metamerism. This metamerism, here what happens is, there is the compounds belong to the same functional group, but they have, but the compounds which have same molecular formula, same functional group, but they have different alkyl groups present around the functional group. There are different alkyl groups are present around the functional groups into compounds having same functional group. Such compounds are called as metamers. So this metamerism, it is shown by those compounds only. This is shown by those compounds only which have non-terminal functional groups, which have non-terminal functional groups. Compounds having non-terminal functional groups will show this type of metamerism. Let me quote an example. Suppose there is a compound CH3, CH2O, CH2, CH3. See, this is an ether. This compound is diethyl ether. Let me write another ether, CH3, CH2, CH2O, CH3. This compound is also an ether, but this is methyl normal propyl ether. This compound is methyl normal propyl ether. It is IUPAC name, or you may call it is 1-methoxypropane. This is methoxy group. This is propane. This is carbon number 1. Then 1, 2, and 3. Three carbon atoms, and on carbon number 1 there is methoxy group. So it is IUPAC name is 1-methoxypropane. And this compound, this is ethoxyethane. This is ethoxyethane. It's IUPAC name. And its common name is diethyl ether. Its common name is diethyl ether. So these two compounds you observe, and these two compounds both are ethers. Both these compounds are ethers, but the difference in these two compounds lies in the fact that around the ethereal oxygen, around the functional group ethereal oxygen, this oxygen which lies in ethers, this is ethereal. This is called as ethereal oxygen. It is always in the center of the carbon chain. That means it's a non-terminal functional group. As I have already told you this thing, that non-terminal functional group means the functional group is present within the carbon atoms, between the carbon, which can't be present at the end of the chain. So this oxygen, ethereal oxygen, it is non-terminal functional group. You see there are two alkyl groups attached to this ethereal oxygen. One alkyl group in this compound is ethyl, and another one is also ethyl. This is why it is written as diethyl ether. Now you see another compound. In this compound there is ethereal oxygen, but around this ethereal oxygen, on one hand there is methyl group, and on the other hand there is normal propyl group. That means in these two compounds, if you will observe, if you will find there are 4 carbon atoms in each: 1, 2, 3, and 4. Here also 1, 2, 3, and 4. That means it is C4. Now you see hydrogen atoms: 3 and 2, 5, 2, 7, and 3, 10. That means C5H10O. यहाँ पर देख लीजिए, 3 and 2 5, 5 and 2 7, 7 and 3 10. That means C5H10 यहाँ पर भी है. तो इन दो कंपाउंड्स में जो डिफरेंस है, that lies in the nature of the alkyl group around the functional group. In ऐसे ही compounds where there are different alkyl groups present around the functional group, such compounds are called as metamers, and the phenomenon is called as metamerism. So this type of isomerism you will observe at all places where there is a non-terminal functional group. For example, another example, ketones are also non-terminal: CH3, CH2, C double bond O, CH2, CH3. Now see this compound. It is diethyl ketone. Its common name is diethyl ketone. Its IUPAC name is pentane-3-one. Pentane-3-one. Pent means 5 carbon, and means single bond, one means ketonic group. Pentane-3-one. Now you see another compound: CH3, C double bond O, CH2, CH2, CH3. Now you see in this compound, once again there are 5 carbon: 1, 2, 3, 4, and 5. Here there were 5 carbon atoms. Here the ketonic group was on carbon number 2, and here the ketonic group is on carbon. Here it was on carbon number 3. Here it is on carbon number 2. So this compound, this ketonic group, here it has 2 ethyl groups on 2 sides, whereas in this compound there is one methyl group on one side, and there is a propyl group, normal propyl group, on the other side. So the common name of this compound will be methyl normal propyl ketone. The common name of this compound will be methyl normal propyl ketone, and the common name of this compound is diethyl ketone, because it has 2 ethyl groups on the 2 sides. Or its IUPAC name, as I have told you, it is pentane-3-one, whereas this is pentane-2-one. So these two compounds are also metamers of each other, because they have different alkyl groups on either side of the functional group. And the same way, you will observe this type of functional group in case of secondary amines. In case of secondary amines. And you know, secondary amines are the compounds which have NH as functional group. Such compounds where there is NH as functional group and there are two alkyl groups attached to this nitrogen. This is why we can make to differ the number of alkyl groups on the two sides, and the isomerism thereby which comes into existence, that will be termed as metamerism. Let me quote one example from this also. Suppose this is a compound CH3 CH2 NH CH2 CH3. This is diethyl amine. Now see, it's another example CH3 NHCH2 CH2 CH3. So both these compounds have same functional group, NH here, NH here. But you see around this NH there are two ethyl groups, whereas in this compound there is one methyl group on one side and there is a normal propyl group on the other side. So this type of compounds or this type of isomerism rather, which exists in these compounds which have non-terminal functional groups, they show this metamerism. So metamerism is the isomerism where there are different alkyl groups attached to the functional group, and these compounds are having the same molecular formula. The compounds having same molecular formula but different alkyl groups attached to the functional group, such compounds are called as metamers, and the isomerism is called as metamerism. So today we discussed two types of isomers in case of structural isomerism. One is functional isomerism and another one which we discussed, that is metamerism. Now there are two more types of isomerism. The one is called as tautomerism and another one is called as ring chain isomerism. Inshallah, we will discuss these two types tomorrow. So for today, it is sufficient. Uh, I hope you might have understood. If there will be any question regarding this isomerism, you may please contact me on my number, on my WhatsApp number, or you can call me. Will help you to overcome the problem. Thank you for today. Very